Hey everyone! Hello again from BitRocket. Today we're bringing you a new review, a 40-foot container designed for 3U servers. My name is Andre, and let's get started. So, let's talk about the container's concept. This is a 40-foot unit with two independent hydraulic circuits. Each circuit is capable of supporting 90 3U servers. Why was it designed this way? Servers can have varying hydraulic resistance. You can load one circuit with 90 S19 3U servers running at 558 terahash, and the other half with an additional 90 S21 3U units at 860 terahash. For ease of operation, the container has been divided into two separate hydraulic modules. Let's take a closer look at the cooling tower. This cooling tower is built with a significant power reserve. Each side of the container uses around 1.2 megawatts. Such cooling towers are rated at 1.5 megawatts each, which means we have a reserve of 300 kilowatts. Thus, the system can operate efficiently in hotter climates and at higher temperatures. All standard auxiliary components are present. You can see the full setup in our previous review. This includes the spray pump, makeup water valve, drain valve, overflow system, control cabinet, and full cabling. Now, let's go inside and explore the container's internal layout. The internal structure. First, the rack frame, our own in-house design. This frame can be configured for both Watts miners and standard 3U servers. Right now, it's set up for 3U units, 15 shelves, each holding one machine. If we were installing Watts miners, it would support 20. Currently, the manifolds are installed for 3U machines, using 3/4-inch connectors and 14mm compression fittings. Have a closer look at the manifold design. The supply manifold, cold side, is straight. Ethylene glycol comes in directly and enters the manifold, so maximum pressure is right at this first fitting. The return line, however, has a U shape. The coolant first enters the far end of the loop, flows down, turns around, and then travels right here. This means the highest pressure will be at this valve here. This is our ladder configuration, the same principle used in the cooling tower. It ensures even pressure and consistent flow velocity. The upper manifolds are designed the same way. If supply enters from one side, return flows from the opposite. This ladder-type hydraulic layout is used in all our containers and stationary systems. It balances the pressure, so no miner is starved for coolant. Every unit gets equal flow. Let's move on. On this side, we have 6 racks, each with 15 machines, totaling 90 miners. Next comes our standard hydraulic section, top-up tank, top-up pump. Right now, some parts are disassembled for transportation. Certain pipes are disconnected. Next, we have the derailleur, flow meter, main pump, sensor system, valves, and filters. We won't go into detail here. You can watch our earlier video on the 20-foot container where we explained each component thoroughly. Here we're just emphasizing that there are 2 completely independent hydraulic circuits, each with its own dedicated pump. The systems are fully separated. You can run miners with different hydraulic resistance on each side. As for the electrics, each hydraulic circuit has its own switchgear, switchgear number 2 and number 1. Each of them is equipped with 3 800-amp circuit breakers, giving each side a capacity of approximately 1.2 megawatts. These 2 switchgears form a fully independent power system. The automation cabinet also supports both circuits with a complete set of components: relays, frequency drives, controllers. Notice the systems are completely isolated. You can even power just half the container. For example, if you bring a transformer station and only have enough power for one side, you can run just this half. The other half can later be powered from a different source. The 2 halves are physically and galvanically isolated. There are no electrical connections between them at all. If we move further down, we'll see the second hydraulic section, which is identical. set up for 15 3U machines, with its own top-up system, deaerator, flow meter, and expansion tank. Here you can see the exhaust fans. Let's walk back again, and I'll show you one more important detail. The air intake grill is located here, because there was no space elsewhere, and the fans are on the opposite side. This creates a full airflow tunnel. Pay attention to this industrial air conditioner. There are two of them, one dedicated to each hydraulic circuit. These are industrial-grade units with water-cooled condensers. The cooling tower serves as the external unit for these conditioners. So, in addition to supplying ethylene glycol to the miners, we also route it through these air conditioners. This allows the system to operate effectively even at extremely high temperatures. If it's plus 50 degrees Celsius outside, and we're using a 12-row cooling tower, this 25 kilowatt electrical power air conditioner can deliver a massive amount of cooling capacity. And the environment of the server room remains comfortable. Just imagine, at plus 50 degrees Celsius, the miners will generate even more heat, creating an extremely hot environment. The residual heat emitted by the miner's chassis is compensated by these air conditioners. This solution is specifically designed for hot climates and can be effectively deployed in regions like the United Arab Emirates, Africa, or any other area with extreme temperatures. We've now covered the key points of this system. Again, for a more detailed explanation of the components and design principles, I recommend watching our previous video, where we break down each part in depth. Now, let's go back outside and take a look at the cooling tower. Let me show you the external hydraulic system. As you can see, the cooling tower uses the ladder configuration. Supply on one side, return on the other. This design ensures balanced pressure and uniform flow velocity. You can see that every connection includes vibration dampers. The entire piping system is included in the delivery package. The cooling tower is pressure tested at our facility together with the full hydraulic system, then carefully disassembled. Each pipe is labeled and documented so you can reassemble it on-site using our detailed drawings. Or if you prefer, our team can come to your location. We'll fully assemble the system, perform pressure testing, bleed all air, start it up, and train your technicians on how to operate it. That concludes our review of the 40-foot container. As a reminder, we are a manufacturing company. We design and build all our systems in-house. This means we can customize solutions to meet your exact requirements. Besides, we also design and build substations and full-scale data centers, both air-cooled and liquid-cooled, in containerized or stationary configurations. We're always available to answer your questions. Contact details will be in the video description. See you next time.